There's something very special about the diatonic scale as it's tuned in the harmonic series. It's composed of very specific frequencies that have an ascendant nature. These are notes that are energetically uplifting. Frequencies defined by Marco Rodin's Mobius circuit as mathematically defined by spirit rather than based in matter. In music, the word diatonic simply means through tones. So a diatonic scale is a movement through subsequent tones or notes. For example, the C major diatonic is a scale running through certain tones between the tonic and octave of C. But the diatonic scale is very different from the chromatic scale between the two octaves of C. In the chromatic scale, 12 notes are included, all of the black and white keys on a piano. But in the diatonic scale, only 7 notes are chosen to be included. In the key of C, those are all the white keys. But in the key of G, the diatonic scale uses this combination of 7 notes. However, in every diatonic scale, the same intervals apply: whole step, half step, whole step, whole step, half step. So why did we choose these 7 notes for the diatonic scale? Let's do a little deep dive into what's special about these 7 notes. Our modern diatonic scale is derived from the process of stacking fifths. We do that by taking a tonic frequency and multiplying it by the ratio of the perfect fifth, which is 3:2. Mathematically, that sorts out to 1.5. So for example, using middle C at 256 Hz, we can stack a fifth above C by multiplying its frequency by 1.5. This gives us G at the frequency of 384 Hz. And the ratio of a perfect fifth, 3:2, is recognized by the fact that for every 2 wavelengths of C's frequency, there will be 3 wavelengths for its perfect fifth of G. When we're all done with the math involved in stacking fifths, we end up with a circle of fifths in the following order. Of these 12 notes, we'll use the first 6 plus the very last in our diatonic scale. But because this order is somewhat confusing, let's just go ahead and reorder the notes for a normal, sequential chromatic scale. Now we see that the notes we'll be using for the diatonic scale have been spread out. There's another way, however, to generate scale frequencies, and that's to consult the harmonic series. Most music theorists tell us that we can build a scale using the following harmonics. This is also a very out-of-order list of notes. But it's much easier to just look at the notes that exist between harmonics 16 and 32. An entire chromatic scale is generated here, and it's in order. As I mention in my book, The Next Octave, this chromatic scale includes 4 notes that aren't acknowledged in our traditional chromatic scale. I've labeled them W, X, Y, and Z. These are all 16 notes, but we can distinguish between 2 types of musical notes, those expressing the power of 2 and those expressing the power of 3. In the Mobius circuit, Marco Rodin shows that the doubling power of 2 is expressed by the single digits of 1, 2, 4, 8, 7, and 5. If a number has more than one digit, you can add them until you reduce through discrete mathematics the number down to 1 digit. And if that one digit is 1, 2, 4, 8, 7, or 5, you know the number is expressing the power of 2. The single digits of 3, 6, and 9, however, express the tripling power of 3. And looking at the frequencies of notes generated in the harmonic series, we can determine if the note is expressing the power of 2 or 3. The harmonic series starts with the frequency of 1 Hz, which is the note of C. Scaled up a few octaves, C reduces, via discrete math, to the single digits of 1, 2, 4, 8, 7, and 5, and in that order. The same is true for the note of C sharp at 17 Hz. Its first generated note reduces to 8, starting the doubling series in the middle. It retains, however, the same order of 1, 2, 4, 8, 7, 5. The next note is D at 18 Hz, which is the second octave of the D originally generated at the 9th harmonic. The note of D is very different from the notes of C and C sharp because, as you can see, every octave of D expresses the power of 3. Reducing in every case to the number 9. Any note reducing to 9 will color yellow. If we continue generating around this circle, we eventually hit the note of F. It expresses the power of 3 by reducing each octave to either a 3 or a 6 in locked oscillation. The note of F never reduces to 9. Two other notes reduce down to this locked oscillation of 3 and 6 that will color pink, the notes of G and B. Every other note in the scale, then, expresses the power of 2, except for the note of A at the 27th harmonic. Like D, the A note always reduces to 9. So all the green notes around the scale circle are expressing the power of 2. And all the yellow and pink notes are expressing the power of 3. But here we need to make a correction, because even the note of C in the context of the scale is being elevated toward the power of 3. All scales are defined by the boundary of the tonic and octave, and though individual C notes express the power of 2, whenever a tonic and octave pair exist within the scale together, they express the power of 3. The octave of 1 Hz and 2 Hz are both expressing the power of 2, but when combined together they add up to 3. Likewise, the octave of 2 Hz and 4 Hz adds up to 6, while the octave of 16 Hz and 32 Hz reduces back down to 3. So what we find is that the 7 notes in the C major diatonic scale are all pink and yellow with the exception of one, the major third or E note. What makes the notes of the diatonic scale special is that these are the notes expressing the power of 3, and it's these notes that produce an upward ascension that's pleasing to the ear. It's these colored notes expressing the power of 3 that form our traditional diatonic scale. But what's going on with E? In my book, I discuss how the harmonic series naturally tempers the note of E away from its sharper frequency generated when stacking fifths. And had this natural tempering not occurred, every note would be expressing the power of 3. And as Marco Rodin says, it's the power of 3 that reflects and expresses ascendant spirit, rather than base matter. This makes the major diatonic scale more spiritual than earthly. If we were going to place the scale into a metaphorical legal jurisdiction, it would fall into the law of the air, ecclesiastical or canon law. And it would be into the boundaries of this major diatonic scale that we could safely place our frequencies in trust, with the hope of being able to eventually reach the next octave. So why isn't the diatonic scale giving us chills, producing ascendant experiences for the ear, the body, and the soul? Why are people complaining more and more that music is affecting society in a negative way, inspiring destructive behaviors and low-frequency states of mind? The reason is because we've changed the way we tune music. We've moved away from certain noble note frequencies and away from the grouping of ascendant frequencies. Our modern tuning method isn't all that new. It was developed in the late 1500s and is called equal temperament tuning. Equal temperament doesn't tune the note of C to its multiples of 1. That's how the harmonic series tunes C, scaling it up from 1 Hz. But while the harmonic series tunes middle C to 256 Hz, equal temperament tunes middle C to 261.63 Hz. Here, I've calculated 2 chromatic scales so we can see the difference in harmonic intervals versus equally tempered intervals. For the tonic, I'm using the equally tempered middle C frequency of 261.63 Hz. On the left is the scale the harmonic series would build. On the right is how the scale is built using equal temperament tuning. The harmonic scale has equal intervals, in this case 16.35 Hz. The equally tempered scale intervals increase at a steady rate, and that increase is based on an equal ratio of adjacent frequencies, producing intervals that start out at 15.5 and end at just over 29 Hz. Looking at the equally tempered C major diatonic scale, the first frequency of middle C, 261.63 Hz, really isn't that bad. That frequency reduces to the number 9, making it an ascendant frequency. The problem comes in with the rest of the notes, the majority of which are based on the power of 2 rather than the power of 3. Comparing the 2 diatonic scales, we see that they're almost complete reversals of one another. Only the E and F notes are the same. The harmonic scale has a third based on the power of 2, colored green, while the rest of the notes express the elevated power of 3. The equally tempered scale has its tonic and perfect fourth expressing the power of 3, with the rest of its notes tempered down into the matter-based power of 2. And if we compare the octave below middle C, C3 instead of C4, it's even worse. The harmonic diatonic at C3 remains the same, but every frequency in the equally tempered C3 diatonic scale expresses the matter-based unascendant power of 2. If you're looking for reasons why today's music might be affecting society negatively, and why modern music isn't more healing and uplifting, you're looking at one reason right here. The discarding of the uplifting frequencies of the harmonic diatonic scale in favor of frequencies that are uninspired and unascendant. I'm grateful for any feedback. Please leave your thoughts in the comments, and thank you for watching.